Good day everyone. Welcome to statistical analysis with software application class. Okay, so for today's video, I'm going to discuss to you about the second lesson of the normal distribution, which is the applications of the normal distribution. Okay, for this objective of this video, of this lesson, at the end of the lesson, you should be able to find the probability for a normally distributed variables by transforming it into standard normal variables. Okay, so how could we do that? Okay, so as part of introduction, the standard normal distribution curve can be used to solve the wide variety of practical problems. Okay, the requirements is that the variable be normally and approximately normally distributed. So there are several mathematical tests to determine whether the variable is normally distributed. Okay, to solve the problems by using the standard distribution, transform the original variable to standard normal distribution variable by using the formula z is equals to value minus mean all over standard deviation, or x minus mu all over sigma. Okay, the standard deviation. Okay, so example of normal distribution. Okay, so we have here the direct application. Suppose that the score for standardized tests are normally distributed, have the mean of 100 and the standard deviation of 15. Okay, so on this part, I'm going to teach you how to transform from more normal distribution to standard normal distribution. So here is our bell curve again. So two factors uh, of the normal distribution is the mean and the standard deviation. And then for the mean, it is the center of uh, the bell curve, or the normal distribution. So therefore, if this is the center, okay, we can assign this one as the mean of 100. Okay, so what is the standard deviation? Okay, the standard deviation is signifies the spreadness or the wideness of the data. Okay, so if you're going to recall the normal distribution, what we're going to do is we add the standard deviation to the mean. Okay, on the right part of this normal distribution. Okay, so meaning to say, on this part of the distribution or the normal curve, okay, we will add the standard deviation of 15. So on this part, we need to 100 plus 15, so that is 115. Okay, and then on this part, 115 plus 15, we have 130. And then on this part, we have 130 plus 15, so that is 145. Okay, on the left side, magmo-minus naman tayo. We need to subtract the standard deviation uh, from the mean. Okay, so 100 minus 15, so that is 85. So 85 minus 15, so that is 70. And then 70 minus 15, so that is 55. Okay, so that is the normal distribution. So now let us convert into standard normal. We just simply change, okay, 100 as 0, 115 as 1, 130 as 2, and then 145 as 3. And then on the left side, we need to change 85 to negative 1, 70 to negative 2, and then 55 to negative 3. So this is the normal distribution, and this part is the standard normal distribution. Okay, so that is how we simply convert it into normal distribution to standard normal distribution. Okay, so applications of standard normal distribution. Example, summer spending. A survey found that the women spend on average of $146.21 on beauty products during summer months. Assume the standard deviation is $29.44. Find the percentage of women who spend less than $160. Assume the variable is normally distributed. Okay, so first thing first, we need to draw the figure. Okay, so since the average is $146.21, so that is the middle part of the curve, and then we need to locate 160 sa curve natin in our curve. Okay, so this is our figure. So 146.21 as the mean or the average, so that is our the middle part of the curve, and then we need to locate 160, so nasa right side siya ng 146.21, so this is 160. Again, we are asked to to find the percentage of the woman who spend less than. Okay, so meaning to say on the left side of 160, so that is why the shaded figure is on the left side of 160. Okay, so find the z value corresponding to 160. So using the standard score or z-score formula, x minus mu over standard deviation. So let's convert x as 160, mu as 146.21, and the standard deviation is 29.44. So that is 160 minus 146.21 all over 229.44. So that is equals to 0.47. Okay, so let us change that into standard normal. So we have 0 and then 0.47. Okay, so now our task is to find the area less than 0.47. Okay, so using the Z table, let us find the area that falls to 0.47. So let's start with 0.04. So this one, and then 0.07. This one. Okay, so the area is 0.18082. Okay, so since that area is from 0 to 0.47, we need to add 0.5 to get the area less than 0.47. So that is 0.180382 plus 0.5, so that is equal to 0.68082. So therefore 0.6808 or 68.808% of the women spend less than $160 on beauty products during summer months. Right, so next, finding data values given to specific probabilities. So here, uh, we need to find the data values, or simply we need to find the x. Okay, so example, police academy qualification. So to qualify the police academy, a candidate must score in the top 10% of the general ability test. Okay, the test has a mean of 200 and standard deviation of 20. Find the lowest possible score to qualify. Assume that the test score are normally distributed. Okay, so here we are asked to find the lowest possible value of score to qualify. So therefore, yung the lowest possible value score is our x. Okay, so what is 10%? Okay, here. Okay, the 10% here is the area. Okay, the area greater than the x, or greater than the lowest possible score. So if the lowest possible score is x, so yung 10% na to is the area, okay, on the right side of the lowest possible score. Okay, so since that is the area on the lowest possible the area to the right of the lowest possible score, okay, we need to find the value of x through this one. Okay, how can we do that? Okay, so here is our the graph or the figure. Okay, first is subtract 0.01 2.5. Bakit 2.5 lang? Kasi ito lang naman yung area na ginagamit natin. Okay, so isusubtract natin to para makuha natin yung area na to. Okay, so that is equal to 0.4. Okay, so next to it is to find the z value that corresponds to an area of 0.4 by looking up 0.4 in the area portion of the z table. Okay, so this is our z table. Okay, so as we can see, okay, so this part, yeah, so we have the closest. Okay, the numbers which is close rather to 0.4 are 0.39973 and then 0.4147. Okay, so pero sa dalawa na to, ang mas malapit sa kanila ay etong 0.339973. So the closest value to 0.4 is 0.39973. Okay, next to it is get the corresponding z-score of 0.39973. So that is 1.2 and then 8. Okay, so that's why the corresponding value of z-score the corresponding z-score of 0.39973 is 1.28. Okay, so that is our x. Okay, so substitute 1.28 as z, rather, that is our z, not our x, to the formula together with the mean and standard deviation to get the value of x. Okay, here is our formula. So substitute natin yung z, the mean, and then standard deviation. So we have 1.28 is equals to 8 x minus 200 over 20. Okay, cross multiply natin ito. So that is 1.28 multiplied by 20 is equals to x minus 200. Okay, so multiply 1.28 times 20, so that is 25.6 is equals to 8x is equals to x rather minus 200. So transpose 200 to the left side. So that is 25.6 plus 200 is equals to x. So that is uh, 225.6 is equals to x. So round it off to the whole number. So that is 226 is equals to x. So the score of 226 should be used to cut as the cut off. So anybody scoring 226 or higher than qualities. So actually this kind of formula this kind of computation are used by universities in order to have the qualifying exam. Okay, so there are they set a certain percentage of the possible score, and then ayun yung kinukuha nila. Okay, so any university uses this one. Okay, so formula for finding z-score. Okay, this one, and then through this we can derive the formula for finding the value of x. So that is x is equals to z multiplied by uh, the standard deviation plus mu. Okay, so that's all for this topic. Thank you for listening and God bless.